Welcome back to Genetics in the Paddock. I'm your host, Emily Johnston, and I'll be taking you along on my journey to learn about all things genetics in extensive livestock. Livestock genetics has always been a topic that's interested me, and now working in the genetic space, it's fascinated me even more with just how powerful of a tool it can be. And I'm surrounded by so many knowledgeable people who are so willing to share their insight, so I thought, why not capture these conversations on a podcast that we can all learn from? In this episode, I spoke with Andrew Swan, a chief scientist at the Animal Genetics and Breeding Unit in Armidale. He takes us back in time on a journey of the history of sheep genetics, reflecting on how far we've come today. So you'll want to stick around for this one. And with that, let's get into it. So thank you so much, Andrew, for jumping on to the podcast today to have a bit of a chat with me. I'm really looking forward to having a discussion with you.
Hi Emily, it's my pleasure.
Awesome. So I think we'll just jump straight into it. So I've spoken to you once other than this podcast, so I don't really know you too well. So maybe we'll just do a bit of a deep dive. Like, who is Andrew Swan? What are you currently working on? What's your role at AGBU? What industries do you work with? Just give me the whole spiel.
Yeah, okay. So I've been at AGBU now for 16 years, but really working in research in mainly the sheep industry, in genetics research in the sheep industry since 1992, I suppose. So that makes 31 years really. So, I came to that via, I suppose, early on. I grew up in the country on a farm, and I became interested in agriculture, and in particular, just the way technology could help people improve productivity on farms. I started to get an impression of that through the late years of my schooling as part of growing up on the farm. So,
was it a sheep farm that you grew up on?
We had cattle and cropping. So that was down near Wagga. So crops were wheat and we had Angus cattle as well. So what actually happened was that some of the people we knew in the district came to the University of New England. So they were a little bit older than me, and so I knew them. And they would come home and you would be talking to them, and it was just really interesting finding out what they were learning at university and how much more they knew about the farms than I actually did.
Yeah.
And I could just see that there was, huge potential for people to do things differently and make things better on their farms. So I came up to university here in Armidale in 1983. So what's that? Now 40 years ago. So I've been in Armidale for 40 years now.
Okay, and you studied an ag degree?
Yeah. So I did rural science, and my original plan was to actually go back and become a smarter farmer.
Okay.
But by the time I got to third or fourth year, I started getting interested in genetics, and I was kind of half good at it too. So people wanted me to do further studies, and that's kind of what interested me as well. So I just got the opportunity to go on and do further studies. So I did a PhD. So I said that I've been at AGBU for 15 or 16 years or something, but I actually did my PhD here at AGBU too back then.
So it's kind of a full circle.
Bit of a full circle, yeah. So that PhD, I was looking at genetic evaluations, and I've been involved in genetic evaluation, so estimating breeding values for livestock species ever since then. So, that's really been my career to look at developing and implementing genetic evaluation systems, I guess.
Okay, so you've had quite an extensive career in genetic evaluations then, so you must have seen a fair bit of change happen over those years and a lot of different trends and all that sort of stuff. So is there anything that you can kind of pinpoint that's been really impactful on your career, or something that's just been a huge wow moment when you've looked back from where you are now?
Yeah, there've been a few, but it has been a long, slow journey really. And, just going back to the beginning, I suppose the industry I've been most closely involved with has been the merino industry. So where that started from when I first became involved in the early 90s to where it is now is a pretty amazing journey. There's a few wow moments along the way, but it's been a gradual progression, I suppose, of change over that time.
So what are some of the key developments that you've seen since the 90s up until now in the sheep industry for, I suppose, contributing to the genetic progress?
Yeah, well, I suppose starting at the very beginning, thinking about what was happening in the 1980s, I suppose, where we are now is a really, quite remarkable across-flock comparison system powered by genomics across a wide range of traits. Back then, there was no across-flock evaluation. It first started developing in the 1980s. So the key thing that you need to have is pedigree information, and to be able to link that pedigree information across flocks. So that what that means in practice is that a system of artificial insemination has to be coming along, and once that happens, you can start thinking about collecting pedigree information. And the first thing that actually happened was a system of progeny testing sires. So those were central progeny tests. So sire evaluation programs started in the late 1980s. So what happened there was that people entered their sires at a central location and generated progeny. They measured the progeny and then were able to evaluate the sires. So people were doing that centrally. Then the next thing that happened was that people learned from that system how they could do their own sire evaluations. So they started doing that back on their own farms. Then the next thing that happened was that people started to realise that maybe we could join all this data together and compare rams across farms, across these progeny testing trials, and just get a much more powerful evaluation.
Okay.
So that kind of developed through the 1990s.
Mm-hmm. And then how did you guys go about joining all of those different data sets together? Because I imagine they would have been quite different, whether it's different measurements at different times or different environments. How did you guys go about going from there to where we are now?
Yeah, so that's actually really interesting, because it was, this was happening through the 1990s, and then towards the end it was happening quite a lot, and it was becoming fragmented. There were different groups that were running different services. So there was a system of central test sire evaluation that was run by the Australian Stud Merino Breeders Association, and we started to join the data together on that. I was actually managing that database for them at the time. Started to join that database together and provide a report that's now called Merino Superior Sires. So that still goes, in fact, but this is just evaluating all the sires that are in central test. And then there was a group at Orange in what's now New South Wales DPI, was then the New South Wales Department of Ag. So that was led by some researchers, Kevin Atkins and Alan Casey. And so they were working with on-farm data more, but they were also involved, we were all collaborating together on the sire evaluation side, but they developed a system called Merino Benchmark that, a dozen breeders or so were putting their data together, and it was linked by sire evaluation. But there was a bit of a problem there, that they had trouble getting agreement from the Australian Association of Stud Merino Breeders to use the central test data to help them link their data.
Ah, I see.
So what happened then was that there's kind of a breakaway group formed called the Australian Merino Sire Evaluation Association. So the people running the trials took control of those trials themselves and kind of separated from the stud merino breeders. They're kind of back together now, but that was a pretty important development, the formation of AMSI, the Australian Merino Sire Evaluation Association. So that kind of allowed Merino Benchmark to continue and, combining all that data. So that was one thing that was happening. Then there was another thing happening basically through the lamb plan system, which was evaluating sheep on the terminal side, and MLA was involved in funding that, because obviously a meat sheep, they're interested in funding meat sheep work. So they started getting interested in merinos as well. So they started up a thing called the Merino Validation Project, which started collecting data on traits that they were interested in: parasite resistance, so worm egg count, and also muscle and fat traits, so obviously of more interest to MLA. But what was actually happening was it was some of the same breeders that were in Merino Benchmark were also in this other system run by MLA. And they were also producing breeding values for the same traits, so not just the worm resistance and muscle and fat, there was also the wool traits and so on. So animals were getting different breeding values from different analyses.
Wow.
So that was all becoming really confusing.
Yeah, okay. So then how did you guys go about like leveling out those breeding values and making them a bit more reliable and consistent?
Well, that was another big moment in the industry. So, the first one being the formation of AMSI, if you like. But then the next one was more people coming together to form what's now Sheep Genetics and the Merino Select evaluation. So that started in around 2003 or 2004. There was, an industry steering committee came together. So it would be people on AMSI, people that were involved in Merino Benchmark, in the MLA's validation project and so on, all coming together to guide the process. And then there was a technical committee. So that's where I came in with other people. So there was the New South Wales Ag people, Kevin and Alan, and Neil Fogarty was another one from New South Wales Agriculture. Then there was the AGBU people, Daniel Brown and Hans Grasser, who was working here before. And I came on representing CSIRO. So that's where I was up until 2006.
Okay.
So that's where I was working on the CSIRO evaluation data. So I came in there with those people and also MLA people, and over a period of about a year, we went through the process of getting all these disparate data sets together and merging them into one with all the issues associated with that, finding out how to identify animals that represented in different databases and making sure they were the same. Yeah, so there's the issue of animal identification. Across the databases, we had to look at how to define traits so that they would be... So we would get accurate breeding values across environments. So fleece weight is actually a really good example here because, it can have really different levels of production across different environments. And one simple thing is that people just shear at different times, so you get less wool just because of shearing time.
Yeah.
So sounds really easy to deal with, but there was a lot of research that went into making that a really robust analysis so that people could be confident in the results. So that was that was a really big moment of people coming together and working together, which was that was a really, really exciting time for everybody that was involved.
Absolutely. It sounds like it was a huge group effort, even just collating all of the data and figuring out how to put it all together and make it a reliable source and everyone can use it and have confidence in what's being put out there. So since you guys have done that, what sort of trends have you seen since, I guess, sheep genetics started, since you guys got everything going?
Yeah, I suppose a lot of it has been about improvements in accuracy. So improved accuracy underpins people's ability to make more accurate selection decisions and increase the rates of genetic gain. So that has been a lot of the story along the way. So back in the early days, merino sheep are typically run in big flocks, and so pre-1990 there was very little pedigree recorded at all. After 1990, people started to record sire pedigree, and then the missing part is then the dam pedigree. So that once you get the full pedigree, you have the ability to get a much more accurate analysis. And then from about 2007, we started, the genomics era started. So genomics has helped a lot of breeders fill in their pedigree. So, you can use it for DNA parentage. But there's also a way of using genomics to increase the accuracy of breeding values. So what you essentially do is develop a reference population. You measure a lot of traits that are hard to measure in those reference populations, and you genotype the animals, and you link the genotypes, the DNA, with the measurements you've made to get a more accurate prediction of genetic merit. So then you can go out into breeders' flocks and genotype those animals and boost their accuracy through their linkage to the reference population. So that's what's happened over time. Breeding values have become more accurate because of better information going into the analysis. People have been able to use that to increase the rates of genetic gain across a whole range of traits.
Okay. So you mentioned that everything kind of kicked off in 2000 2004.
Merino Select
Yeah.
started 2003, yeah.
2003.
2005 it was actually launched. We were researching it from over that time.
And then you said genomics came in 2007.
Yeah.
So have you seen genomics become something bigger?
Yeah,
There's
absolutely.
a slower uptake in genomics compared to performance recording, and how's that kind of compared based on the difference between the space where genomics wasn't used at all?
Yeah. So when I say 2007, that's when the first reference populations started. So that takes a little while to develop. So you have to build up a reference population of thousands of animals. So that happened through the sheep CRC from 2007 through 2011, build up the reference population, and then you establish a genomic prediction. Breeders genotyping probably started around 2011. The CRC ran some pilot projects, and what's the issue with people genotyping now was just the cost. It cost a lot of money back then. So as time's gone on, the cost of genotyping's come down. So more of it can be done. So those pilot projects ran from about 2011. Breeders being subsidised to genotype a small number of animals just to see what would happen to their breeding values. Then that started to accelerate as the prices just came down, and 2016 was the next big thing for us, was where we actually developed complete genomic evaluations. So Merino Select in 2017 became a full genomic evaluation where we use all of the old data on pedigree and performance traits, plus we bring in genomics. So not every animal's genotyped, but every animal is used. So they're all in the system. The reference population is there underpinning the accuracy through the genomic breeding values, and that's all getting incorporated with the pedigree information and the performance data information on farm in a kind of seamless way. It's actually really cool.
Yeah,
that works. Yeah,
that sounds really interesting.
But what's actually happened in merinos, if we look at industry now, is we've got a system where we've got about 250,000 animals coming into the system per year with their pedigree. Probably around 80,000 of those animals are genotyped now.
Okay.
So we're starting to, I would think within the next year, we'll have 500,000 animals genotyped in that analysis.
Wow.
With a pedigree of about 5 million animals. So analysed for a whole range of traits, more than 50 traits. So animals are getting these really accurate breeding values. Breeders are getting these really accurate breeding values.
Yeah, I was just about to ask that, because there are so many animals genotyped and their performance recorded, that would naturally increase the accuracy.
Yep.
Because the resource population or reference population is quite big in that sense.
Yeah. So the thing is with the way we do the analysis is that whatever a breeder measures, they're actually contributing to the reference population themselves. So that typically happens for traits that are easy to measure. Yeah. You keep the resource flock, the central funding flocks, going to measure hard to measure traits that breeders are too expensive for breeders to measure. But what's actually happened is that because of that increased accuracy that's happened over the last few years, the genetic gains that we're seeing are 1.5 to 2 times greater than they were from 2000 to 2010. So the industry's just making a big leap forward in genetic progress.
And what strategies do you think they've put in place to make that genetic gain? Or if there's like a new merino producer getting into it, what would you suggest them to keep following that trend of 1.5 to 2 times genetic gain?
Yeah, so a lot of it comes down to data quality. So, and using the information that's already there. So if you're just starting off, you can look at the database to identify superior animals that are going to help take you forward. You can make sure that your on-farm data is as accurate as it can be. And one of the things that people are doing now is just using genotyping to make sure their parentage is really accurate. Using EID technology and all the recording technology that goes with that to make sure that you're getting accurate data and just putting all that together into a system and getting the right advice and
using all the tools that are kind of available in the best way. Yep.
So you have the breeding values that come out of that system, and then the other tools that we have are selection indexes, which combine the traits appropriately weighted by their importance. Mm-hmm. So there are a range of indexes to meet that, and that's one thing that we've just released new indexes to help that process. And then tools like MateCell, which takes breeding values for your potential parents and works out the ideal matings to optimise genetic gain with making sure you've got diversity and you're controlling inbreeding.
Okay, it sounds like there's a lot of really, really useful tools available for people to make those decisions and select superior sires as well to enter into their breeding program and their system. I am curious though, because you've had quite an extensive career in genetics, if you had a crystal ball and you were looking into the future, say 10 years time, what do you see whether it's genetics as a whole or the sheep industry, what do you kind of see that looking like? Or do you see any opportunities or challenges at the moment that might kind of rear its head in the next 10 years?
Yeah, well, I suppose what I'm really interested in, I've spoken a lot about breeding values, but I've always been interested in how you use breeding values in the best way. So I was just mentioning the use of indexes and how we've developed new indexes. The traits that people have focused their breeding on up until the last 5 years or so have kind of been simple output traits. So you're looking at fleece cut per head, so fleece weight, and the value of wool, so through fibre diameter, and growth rates, turning off lambs faster, and simple reproduction traits. Where we've started to head is to look at other traits which address issues like welfare and sustainability and resilience to climate change and so on. So, I think that we've got a lot of those traits have come online over the last few years. A lot of the necessary traits have come online. So we've got things like new, more sophisticated reproduction analyses which allow you to target things like lamb survival and balance that with improvements in litter size. For example, we've got traits which address welfare like breech wrinkle, disease traits as well. So we've already got some of that, but I would think that will develop more. We might see wrinkle is meant to breech wrinkle is meant to address the mulesing issue, which is mulesing is a big welfare issue in the industry, has been for some time now. But we've got this breech wrinkle tool that can help take wrinkle off sheep so that you don't need to muse them. But the reason for mulesing is to combat fly strike. So we might see the development of more direct breeding values directly for the disease trait itself, so fly strike resistance. So we might be able to do things like that. There's a lot of interest around now in sustainability, and people are concerned by the contribution of ruminant animals to climate change through emissions of methane. So we've got programs that are looking at measuring methane in animals. So just how you use that information to in breeding programs is that's the thing that's going to come along in the next 10 years or so, and bringing that all together into an overall package, as I've described, through the breeding values that you can provide, the tools through indexes that you can combine them, and so on. That's going to be what's going to happen over the next 10 years.
It sounds like there's a lot that's going to happen, and there's a lot of different avenues that people might go down and explore, whether it's welfare or sustainability, climate change, all that sort of thing. And it sounds like you guys have the very, very fun job of trying to package that all together and figure out how to deliver that and how to put it all into a format that people can use. Yeah,
well, the challenges are really big, but we have really good tools to address those challenges, and there's plenty of opportunities for people, say, young people wanting to get in the field to do exciting work into the future, I think.
Absolutely. I think it sounds like it's a field that's always evolving, and there's lots of work to be done by the sounds of it, so a great opportunity for as you said, young people to jump in and harness their ability and jump into a new skill and learn something new?
Yeah, well, what I've found really rewarding over the years since I came in to the area and started doing research was that you were providing information to breeders to help them, improve their businesses, and you can actually measure that through looking at the genetic trends in important traits over time. So, that's a really rewarding thing. I think that you can see the value of what you're doing directly.
Absolutely,
and the widespread impact of that.
That would be very fulfilling to know that the work you're doing is actually very beneficial and you can see the value of that. And I suppose it would make you just want to continue what you're doing and keep along that track of, helping these people. All of the data that you're collecting and all of the work that you're putting into it behind it is having this large scale effect and driving the industry forward.
Yeah, definitely. No, absolutely.
Awesome. Well, thank you so much for having a chat with me today, Andrew. It's been very interesting hearing about your insights over the last 30 years working in the genetic evaluation system. And it's been really cool to hear just about the history of it and how it all came together. It's definitely come a long way from the sounds of it.
My pleasure. Thank you, Emily.
Thank you. Thank you for tuning into this episode of Genetics in the Paddock with Emily, a podcast produced by the extensive livestock genetics team within New South Wales DPI. We hope you've enjoyed this deep dive into the world of genetics and its impact on livestock production. If you found this episode informative and engaging, please consider subscribing to the podcast and leaving a review. Your feedback is essential in helping me to continue to bring you valuable content on livestock genetics. If you have any questions, comments, or suggestions for future topics or guests, please don't hesitate to reach out to me on social media or through email. We love hearing from our listeners and are always eager to explore the subjects that matter most to you.